So this is what we have. Examples of numerical fractions. Numerical meaning we don't have letters, we don't have unknowns, it's just all numbers. So here we have numerical fractions in different forms. We've got positive, we've got negative, we've got proper and we've got improper fractions. So all familiar with that. Now for algebraic fraction, we've got P and Q, they are real numbers, and Q is not equal to 0. Real numbers meaning any number you can think of. Okay? Examples of algebraic fractions of different forms. You may copy these down. These are just some examples. Okay, over here. The fourth fraction. Okay. I think we can move on to this. Let's do this by ourselves now. Right, and algebraic fractions remains unchanged when both its denominator and numerator are multiplied or divided by the same non-zero number of expression. What does this mean? Let me explain to you in your primary school maths. 3 over 6. What will you do if you have 3 over 6? Divide by 3 on both sides, right? So you will divide this by 3, divide by 3, and we get 1 over 2. Are they the same? 3 over 6 and 1 over 2, are they the same? The value is the same, right? Okay, how about instead of dividing by 3, what if I choose to multiply by... What would you like me to multiply by? 2? Okay. Let us multiply this by 2. And then multiply this by 2. So I get 6 over 12. Are they still the same? Yeah, they are still the same. So that is what this note is trying to tell you. When you multiply or divide by the same non-zero number of expression, the fraction remains unchanged. The value is still the same. Let us say non-zero number. What if I choose to multiply by a 0? I want to be funny, I want to try. What if I multiply this by 0? Can this work? Numerator multiply by 0 can? Okay, denominator 6 can multiply by 0? Can, right? Can multiply by 0. Okay, let's see what happens. So we get 0 divided by 0. Is this not a problem? Is this a problem? Why is it a problem? Because you can't divide by 0. Okay, so they say it must be a non-zero. So you cannot have division or multiplication by 0. Right, so this works the same for algebra. Okay, P over Q is the same as P over Q. Both numerator, denominator multiplied by something, as long as it's not 0. Same as divided by something, as long as it's not equal to 0. Okay, so 4 over 6 must therefore be equal to 2 over 3. Done. Can I go faster? Okay, I see you nodding your heads. We can simplify an algebraic fraction by extracting the common factor of both the numerator and denominator. Now this should tell you that it involves factorization. Are you familiar with factorization? The previous chapter, we've done lots of factorization. Okay, and what we were doing in primary school was actually factorization also. Let me show you how. Before you tell me 4 over 6 equals to 2 over 3, there is something happening in your mind. This is what is happening. You chose to divide by 2, right? Obviously you choose to divide by 2. Why 2? Where did this 2 come from? Is it by instinct? No, because you have practiced so much already, you know that straight away 4 is 2 times 2 over 3 times 2. Because you have practiced so much, you know that this is going to happen. And we can therefore cancel these 2 out. And we are left with 2 over 3. Okay? Let me give you another example. Let's say we have 12 over 14. Okay? Now 12 over 14, you have an option, right, to factorize it. 12 has factors of 1, 2, 3, 4, 6, and 12. 14 has 1, 2, 7, 14. If I want to factorize these, 14, I have no choice. I'm going to obviously leave it as 2 and 7. Now in my numerator, will you choose 4 and 3? Will you do this? Will you? You won't. Why? Because you know that, hey, actually 2 is a factor as well. And if I do it this way, I'll be able to cancel away the 2. Therefore, leaving my answer as 6 over 7. So this process over here is called factorization. And we're going to apply it to algebra as well. Okay. I'll show you the answer for this. Explain why the following steps are incorrect. So here we have x squared times x plus 2 over x. And then we try and factorize. Then the student decides to, hey, let's cancel the x in the denominator and this x in the bracket. Okay, and this is wrong. Because in the numerator, this x inside the bracket is not a factor. Rather, this is how we should be doing it. We should be dividing both numerator and denominator by x. That's why in the numerator we've got x squared, which is simply x times x. When I divide it by x, I'm left with simply x. My final answer is x times x plus 2. Now let us do simplification. A squared b over a b power 5. And I'm sure you can do this. A squared b over a times b to the power of 5 must be equal to, cancel away the square, cancel away the a, cancel away the b, 5 becomes 4. So my answer will be 1 over b to the power of 4. Okay. Now part b. This is a little more challenging. What? Oh, there's an A. There's an A in the numerator. Thank you. Now part B, slightly more challenging. What can we divide by? What can we? They are already grouped nicely into factors for you. Okay. So your choice. What do you want to divide the numerator and denominator by? The y plus 1 term or the x plus 2 term? It doesn't matter, right? Let me just divide by the y plus 1. Then I divide by the x plus 2 square. So I'm left with y plus 1 over x plus 2. What? Y plus 1, what about it? Oh, yeah, there should be a square. I thought this was a 2. Okay, so this becomes a square, like this. Right? Thanks for pointing out my errors. So this tells me that, hey, actually you are familiar with all these things, huh? So let's go straight into example number 1. How long do you think you need to finish all these? Is 1 minute too short? Okay, 2 minutes, 2 minutes. For A to D. Let's check answers. I'll do on the spot. Tell me if I make any mistakes. Yeah, that's my first answer. Okay, am I right? And are all of you right? Okay, good, good. Okay, now we come to factorization again. How long do you think you need for A to D? 2 minutes? Okay, 2 minutes again, huh? So we'll stop at 8:29. Part A. This is obviously 4 times of y plus 2. Please self-mark. Okay, and the next one, this must be a multiplied by a minus b. This is x squared minus 5 squared, which is x plus 5, x minus 5. Okay, I'm using this this special product over here. And the last one, this is actually 3y square minus 5 square, which gives me 3y plus 5, 3y minus 5. Then I would like you to take a highlighter, highlight these two questions. Because if I were to set the paper, I will make sure these will come out. But I'm not setting the paper, so I don't know whether it will come out. But if I am, I will test this, definitely. Because everybody knows how to do A and B, right? C and D is what we want to test. So we have another 3 more questions on the next page. Again on factorization. How long do you think you need for these 3 questions? 3 minutes? Okay, we give you a little more time, 3 minutes. So we'll stop at 8:34. Do you have these answers? Part G and H, they are factorized based on what you learned last year in Sec 1. Factorization by grouping. Now, I will choose to use the cross method. So on this side I have x squared. Then I have 8, and I've got negative 6x. So I need to fill in the blanks with a cross over here. On the left hand side, it must be x and x. That's the only way for me to get x squared. On the other side, in order to get 8, I can choose to use 1 and 8. I can choose 2 and 4. But using some quick mental sums, I know that 1 and 8 will not result in a 6x. It has to be 2 and 4 because 2 plus 4 can be equal to 6. So let's just put a 2 and a 4. So with this, I will multiply x times 2 gives me 2x. X times 4 gives me 4x. Now 2x and 4x, they look like they can give me a negative 6x. How? If there's a negative 2, if there's a negative 4. But I can't simply change that without changing my 2 and 4. So I need to put a negative sign in front of the 2. So that x times negative 2 gives me negative 2x. I put a negative sign in front of the 4. So that x times negative 4 gives me negative 4x. Then would this result in a problem for my value 8 over there? Is that going to be a problem? No, there's no problem because negative 2 times negative 4 still gives me 8. So this is my answer. X minus 2 multiplied by x minus 4. So you need more practice for this type of question. Part F. Now moving on. These are your 4 methods that you have learned for factorization. And just break this down. This is in primary school. This is in Sec 1. These 2 are in Sec 2 that you have learned. Simple factorization, just take out whether it is 2 or 3, whatever the factor is, take it out. Grouping method, you learned it in Sec 1. These are the 4 terms. Okay, and then B and C, we just learned them. Then you must always check if the numerators and denominators are fully factorized before you can simplify. Okay, so let's do some examples. I'll do the first one with you, part A. 4y plus 8 divided by 2y minus 6. So, factorize the numerator and the denominator. What is the common factor in the numerator? 4, okay. Then we're left with y plus 2. What is the common factor in the denominator? 2. Take 2 out, we've got y minus 3. How do we simplify now? 2 and 4. Okay, so we're left with 2 times y plus 2 over y minus 3. Simple? This is our final answer. For your numerator, you can leave it as 2 times y plus 2, or you can expand it out, it becomes 2y plus 4. Doesn't matter. Now, part B. Do you think you can do it yourself? Come on, I'm sure you can. I give you a bit more time. Let's take 3 minutes for this. We'll stop at 8:41. Okay, so we have x minus 2 divided by x minus 4 times x minus 2. Right? Okay, now, what is the common factor? The x minus 2 is the common factor. If you're uncomfortable, we can always place it in a bracket. And then you can say it away. So we're left with 1 over x minus 4. Alright, and then the last one. How long do you think you need for this? 30 seconds. 30 seconds. Okay, we start at 8:41. You like part C? Why not? Is it difficult? No. X squared minus 4 is simply x squared minus 2 squared divided by x plus 2 squared. X minus 2 x plus 2 divided by x plus 2 squared, which is x minus 2 over x plus 2. Okay, so the trick, okay, not really a trick, this part. We are again using a squared minus b squared. I told you we will test it, right? Okay, so far, anything very difficult? Is there anything very difficult? No, I think it is manageable. You just need some practice. Okay? So let's try part D. Let's take 2 minutes for part D. 8:44. Let's start with the denominator. That's the easier part, right? Okay, what do you have for the denominator? 4 squared minus x squared must be 4 plus x, 4 minus x. That is my denominator. And then the numerator looks a little more challenging. In order to factorize this, I need to use this method again. 3x squared. Then here I've got negative 8 and negative 10x. Put in across. It's time to fill in the blanks. Do you want to start with 3x squared or 8? 3x squared, because no choice on. We've got 3x and x. It must be 3x and x, no other way. Then let's move on to the 8 part. What are the options that we have? 2 and 4. What else? 8 and 1. Okay, we can flip that around. Which one would you like to try? 2 and 4? Do you see there's a possibility of getting a 10 out of the 2 and 4? Let's try. If I put the 2 over here and 4 over here, just by looking, do you think it is possible to result in 10x? Okay, you are seeing it already. Let's try. Again, I'm not putting in the signs yet. So 3x times 4 gives me 12x. X times 2 gives me 2x. Now it looks like it is possible to get negative 10x from 2x and 12x. So what should I do? We'll put a minus at 2 or 12. Put a minus at 2 or 12 in order to result in negative 10. 12, okay? Put a minus sign over here. If there's a minus sign in front of the 12x, where must this minus sign go to? 2 or 4? This negative sign, should it go to 2 or 4? 4. So that 3x times negative 4 gives me negative 12x. X times 2 gives me 2x. 2 times negative 4 gives me negative 8. So this fits. In other words, my numerator becomes 3x plus 2, x minus 4. Okay? Hey, then can factorize or not? Is there anything to cancel? Is there anything to cancel? Nothing. Come on, something you learned in Sec 1. There's something we can do. What do you notice? If only what? If only x minus 4 becomes 4 minus x, then we can cancel something, isn't it? But how do we make that change? Okay, let me remove this first. If only x minus 4 becomes 4 minus x. And we know we can do that by multiplying it by negative 1, right? But can I simply just multiply by negative 1 and expect everything to be the same? Cannot. What should I do? If I multiply the numerator by negative 1, what should I do in order to make the fraction the same? Multiply negative 1 to this part. Is it now the same? Same, right? Alternatively, I can also put a minus 1 here also, right? Isn't it all the same? Right? These two effectively equals to 1. Multiplying by 1. No difference. Okay? If I don't put it over here, I put it over here. These two again still equals to 1. Still no change. Up to you. What do you like? Okay? So let me just leave it like this. Now I'm going to divide. No, I'm going to continue first. So this gives me 3x plus 2 with a negative 1. And now this becomes 4 minus x divided by 4 plus x with a negative 1 with 4 minus x. No. This negative 1 disappears already. Sorry, I made a mistake. This becomes 4 minus x, yes, like that. Okay, because I multiply this negative 1 into this bracket. Right? So now it's time to cancel. My final answer . These are all correct. They are all the same. Just which one do you prefer to see? Personally, I prefer the first one. So I put a negative sign outside. Over here. Okay? Would you like to try part E in class or at home? Class, because you want me to help you, isn't it? Okay. And you're left with the answer. X plus 5y over 7x minus y.